All right, there we go. So yes, once again, welcome everyone. Again, thank you for joining. We're super excited to be meeting today for our Growth Sector Employer Speaker Series. Today we have a super special guest joining us. We have Professor Charles Liu, who is from Cal State LA. If you're not familiar, it is in Los Angeles in California. And he is with the Computer Science Department. And we'll be discussing some really great opportunities through their SMART internship program that will be available this upcoming summer. Just a reminder for all of our STEM course students, our internship application will be opening up next week. Woohoo. So definitely keep an eye out for information regarding that from your support specialists. They will be sending you the link to be able to apply. With that being said, you do need to make sure that you have your STEM resumes ready. So if you have not already met with a support specialist or even like the career center at your campus, definitely make sure to do so. Get those resumes ready to roll, because that is going to be part of the requirement for the growth sector internship application. You do need to submit your STEM resume. And then through our program, we also have available to you one-on-one resume appointments that we will make sure to also share the link for, so you can set up appointments to do that as well. So without any further ado, I don't want to take any more time away. I'm going to pass the mic over, like I said, to Professor Charles, who is going to take it away.
Thank you, Mara. Hi,
Yeah.
everyone. My name is Charles Liu. I'm the faculty member at Cal State LA. Cal State LA is around 14 miles north east of downtown LA. So we're quite close to the LA downtown area. So this has been the fourth year since we started working with Growth Sector STEM Core on the summer internship program. I'm very proud of it, and I think this is truly rewarding program. In STEM Core, as Mara mentioned, is going to work tightly with you. I believe you've been through the program for the bridge internship and everything, the preparation for your transfer experience. But there's another milestone that is available for you. Highly encouraged to pursue during the summertime. That's the purpose why I want to introduce you the program at Cal State LA. So in the previous 3 summers, we served. The first year was a pilot study. There were 6 interns, and then we have around 15 to 20 in each year during summertime. So mainly you spend the time with us. Highly recommended to come over to us during the pandemic time. Although there's a specific duration that we offered it in a hybrid mode and fully remote in one of the summer, but now, since it's wide open, then we highly encourage you to come to us in person. But of course, it's open to students across the nation. And then for the past summer 2023, there were 4 students from the East Coast. Yeah, so just need to remember that the time difference, all right, whenever we schedule the meetings. Without further ado, let me show you a quick presentation, but feel free to just chime in or type your questions in chat, and Mara would be able to just remind me, and then I can pause and answer your questions, or your if you have any comments, feel free. All right, do you see my screen? Okay, good. So again, we're at the College of Engineering, Computer Science, and Technology. At Cal State LA, in the college, we have 5 departments: computer science, electrical engineering, mechanical engineering, civil engineering, and the technology department. So we emphasize the hands-on experience at CSULA. Within the program, there's a Bachelor of Science as well as a Master of Science program. So as I mentioned, we've been fortunate and I'm very glad that we could work with growth sector for the past 4 years. Myra knows that we're still pursuing future opportunities to develop a apprenticeship program, so students can be prepared from the very beginning to steer toward a STEM field of your interest based on your major area. So that we work with our industrial partners, and so from the STEM core program, you could start with the Mesa at your own community college, and then transfer to a 4-year university. If you're choosing CSULA, then there will be some internship opportunities along with the summer workshops and summer programs to prepare you for specific demand from the industry. So that's what we're working on. If you're living in the Southern California area, the industry here mainly is the aerospace industry in El Segundo area, close to the LAX. But of course, there are all different engineering industry in the surrounding area. So we plan to work with our partners, including Raytheon, Boeing, Northrop Grumman, Aerospace Corporation. Of course, there's also Southern California Edison, the power company, LADWP, which is the LA District of Water and Power, and several other companies, Caltrain, so on and so forth. So there are Lockheed Martin, and those are the companies that are surrounding us, and then we are trying to reach out and provide this degree-based apprenticeship program, so we can prepare you not only through the summer internship program, but it's going to be a long-term pathway for you to be prepared specifically for the demand of the industry. But let me just focus on the summer program. That's a focus for today. So that's called a SMART internship program, standing for Summer Making, Academic Prep, and Research for Transfer Students. It's an internship program. So STEM Core helps us to recruit students and interview students, making recommendations and providing your CV, your resumes to us. So then the CSULA team will review the applications and invite individual ones to the internship program. So later I'm going to give you the details, but let me give you some background about this and what technologies are involved. So as I mentioned, this is offered by CSULA or CSULA with the collaboration with Growth Sector STEM Core. So you can participate in the workshops during summertime. All right, during summertime. So that involves some making hands-on experiences, right? It's not a lecture course. All right, it's just hands-on. You're gonna form teams with other peer interns, being guided by the mentors and also the faculty advisors. So there will be facilities for you to use physically and virtually, because a lot of these are the apps, so that for simulation, for some numerical studies and machine learning, those kind of things, to help you get familiar with the engineering, computer science, technology tools that are widely used. Academic preparation, because we also want to make sure that you find your interest. In the past years, there were not only engineering students or computer science students, there are also some students from different majors, for example, biology, chemistry, chemical engineering is engineering. All right, so chemistry, architecture, there are students from different fields, but we want to make it generic. And then also because a lot of technologies nowadays are very critical, no, regardless what application domain you're going to focus on, right? Even social science, even political science, even if it is health related fields, right? They're all, you all need regardless, you need the technologies. So that's what the purpose is. And also because there's no prerequisite knowledge required. Of course, we expect that you're interested in a STEM field, but there's no hard requirement in terms of the calculus or programming skills, because we're going to train you from the beginning, start a training from the beginning. So it's more about eye-opening. It's more about exposure provided to you about the current technologies. All right, so and later on, I'm going to show you more about this. And it's focusing on and also there's research part that you work with the faculty to conduct some research, maybe some data collections, maybe some analysis of the data, maybe some graphic part of that. You can draw some chart to do the to visualize the data and so on and so forth. And this is for pre-transfer students, and the program is open for pre-transfer students. Although there will be some activities that you will work with Cal State LA students, same age, it's about the same sophomore year students or junior year students. So you're about the same age, to form cohort that you can work together to form the collaborative learning environment. These are, I just want to start with some pictures to show you some examples. For example, this is a maker space. Over there, you can see a lot of machines, and for the cutting, for the soldering, for also the 3D printing. So all these kind of work, sorting of the different parts from it's deassembled from a larger system, and then also some so this is an interesting project. So there's a robot here, we call it a rescue robot. So basically there's a rover. On top of that, there's a robotic arm, and a camera is mounted on top of that. So on the other hand, the operator could wear a pair of goggles, which is connected to the robot. Of course, this is a prototype, and then we show the wire between the goggles and the rescue robot. But in reality, it's going to be wireless. All right. So through that, the operator, the rescue operator, could just move the head. There is a gyro sensor on the goggles. When you move the head, and the robotic arm is going to move accordingly, so that then the camera is going to pass the video frames back to the camera, to the goggles. So the operator could have the hands free to operate on other parts of the road. You can put a joystick there, could be some controller there, but with it's hand free, right? So you could move the head and see what the robots see. So this is invented for the hazardous environment aftermath. Let's say if there's an earthquake, then, by the way, there's an earthquake drill in a few weeks. I'm not sure. It's Southern California. I don't know where you are, but it's going to be 10/19, October 19 at 10:19 in the morning. So anyway, so that's a big thing. So with this robotic rover, basically we can send this to where not accessible by human beings, by the human rescuers, and then we can operate the robot remotely and then hand over some first aid to the victims, right? So that's an example. And also students work in the lab on we call it an FPGA, field programmable gate array, which is a hardware that you will be able to define what you want it to do. For example, you could define, hey, I want this FPGA to be a controller for the autopilot function. That's one example. And later on, we could also say, hey, I want use this one for a drone. It's a drone controller. So that's about not only about the programming, but also the hardware. We can directly play with the memory. If you have a computer, you know that there's a CPU, there's a GPU, there's also some memory space. There's also some peripheral connections to USB to the other peripheral devices, let's say a mouse, a earbud, to a keyboard, and so on, right? So that's typically a computer. So typically, if you have a laptop computer or a desktop computer, it's already fixed. The architecture is fixed. So you only program on the fixed architecture. But for an FPGA, that's what they're doing. It's here. It's a better picture to show that this is a small FPGA board that they could define the logic. And then, as I mentioned, it could be multifunctional, right? So that I attended a meeting with the Intel people, and they use FPGA. And I asked why FPGA? Why are not using your CPU? They said that they're using FPGA to test their CPU. So they use FPGA to manipulate all possible situations. Could be hacks from hackers, could be some internal, the blue screen thing. That's the last thing you want to see on your computer, right? That means your laptop is dead. You have to restart and hopefully it could be recovered. So those are the scenarios the manufacturers want to avoid. They use the FPGA to manipulate all those kind of events right on time. Because if you do the software, then you cannot guarantee how fast you want it, when you want the event to happen. But using the FPGA, then you can define exactly what you want. So anyway, that's something that we had during the summer. And there's also this is you see a doll here to mimic a shower room with a patient sitting in the tub of a shower room. So the robotic arm is going to become a dispenser for soap or for the body wash, so that the patient doesn't need to operate with the hands, right? So I'm going to show you a video accordingly. So those are examples. These are the interns. These are our interns. Yeah. These are in the STEM core program previously. Maybe they're still there. All right. So those are the examples. Other examples include, you see, oh, this is biological thing. This is actually autonomous watering system. So depending on the humidity of the soil, depending on the temperature, depending on the weather, there's sensors to determine this condition. And then based on the condition, there's a controller to determine when to sprinkle the water and how much water is going to be dispensed, right? So that's something to do with engineering discipline for agricultural related work, right? So you could imagine how engineering and computer science are impacting your world. So they're working also on the software part to determine how to organize the information. So there's also the data collection part, the data sorting part. The other example, it was a lady. She was also in our STEM core program as an intern. So this is a lab in this is our biological engineering lab. So biological is a field which needs a lot of discipline from biology, engineering knowledge, and also computer science related skills. So where do we use biomedical engineering? For example, MRI, CT scan, right? Those are the machines the instrument that used constantly in hospital. So that's for medical applications, but that needs a lot of signal processing, needs a lot of the data acquisition, that needs a lot of engineering background. The other example is the wearable devices, right? So for example, the smart watch, there nowadays the smart ring. Have you seen that? The same purpose, right? So those are actually collecting the vital signals, like let's say your pulse, your body temperature, the oxygen density, and so on and so forth, right? There are a whole bunch of different sensors. Whenever you see sensors, that's related to the engineering field. But the data has to be collected, but it's actually analog signal from your human body, right? And then the signal has to be converted to a digital way, because the smartwatch need to communicate with your smartphone, right? If you wear a, let's say for example, there could be some sensors that are put on the patient's body, and then the signal will be transmitted to the hospital for monitoring purposes or for analytical purposes, right? These are happening in all different applications. So with that, that involves engineering discipline. So what the lady does was to be the guinea pig to put on the helmet with a lot of sensors on her head. It's not intrusive, no worries. She doesn't feel pain. On the other picture, she's showing thumb up. So it's no pain at all. But this is our graduate student who's helping to show her the different signals, and she was happy. But this is a cable to convey the data to the computer, and then the student can process and then visualize it. So that's about. So I just want to give you a flavor of the applications. Before I go to the details of the arrangement, I also want to show you a YouTube video. This is the B Winners program. That's the first year STEM Core Smart internship program. At that time, we received the funds from Xilinx, now being obtained by AMD in Silicon Valley. AMD is the competitor of Intel, right? Is the manufacturer of the chips. But anyway, this is a biomedical engineering women initiative innovators. I forgot again. It's another acronym. And Myra and I were talking about the difficulty of remembering the acronyms. But that's at that time we recruited. At Cal LA, we recruited female students to work in the project so that they could develop the shower robot. As I mentioned, I'm going to show you the video. But through the STEM core, we also recruit other pre-transfer students, community college students, to join the program. Could you hear the sound?
Yes.
All right, to be continued. Yeah. So that means um, that's your job, all right, to continue with the design, and there are still a lot of work remaining for you. So this is the next prototype in the past year when the interns were working on it. So we could uh, just use this a miniature demonstration of um, the system. Right. So the idea is to allow, it's a biomedical engineering instrument to allow a patient during the rehab not being needed for using hand much, but there's a camera to determine the position of the patient. And then also the robotic arm, you could see that involves a lot of mechanical engineering discipline to determine the degree of freedom, the degree, the pitch, the roll and yaw, respectively, of the robotic arm. And also for the computer engineering part, the camera, after determining the position, has to send the signal to the controller. So the robotic arm is going to move accordingly. And that involves the hardware, computer hardware, as well as the computer software, because you need to develop the code to operate, determine how the robotic arm is going to react. Right. So that involves typically, this is an engineering project that well, just in this example. So I've shown you one as example as the rescue robot, and this is another one showing the shampoo dispenser for a biomedical engineering application. So let's go back to the arrangement. So we expect you to work 40 hours a week for 8 weeks in summer. Usually we start in the mid of June with the consideration of your when the most of the community college finishes the spring quarter or spring semester. Okay, so usually it's the mid of June. Most activities could be conducted remotely, but it's highly encouraged that you can come over to make use of our facilities in our maker space, in our lab, and the research instructional lab, as well as the research lab. Instruction lab is basically to conduct the experiment, the basic hands-on activities. But there's also research part. You will be a group of students will be assigned based on the discipline. You will be grouped, and then you will be assigned to a advisor with some interesting project that is related to your major. Right. So that's the so there are two parts of work mainly that's shown here. The distribution of the workload is 30 hours for the required workshops and another 10 hours for the research part. So for the plenary workshops, all interns will gather together for the workshops. That covers some materials. In the past, we covers the Intel DevCloud, FPGA, machine learning, computer vision, Cadence, Linux, MATLAB applications. I don't want to overwhelm you, but a lot of these involves some programming, some simulation, some graphics, some numerical methods that are widely used in the STEM discipline. So that's about the 30 hours per week workload. There will be some in the workshop, there will be some workshop that you will meet with the graduate assistant weekly. All right. And then there will be self-paced parts that you need to work out some homework. And then there will be office hours to answer your questions, or you can meet with the graduate assistants to work in person, face-to-face. And the subjects include the current technologies. Trust me, these are very crucial, and then these are mostly not covered in the curriculum, because they're not lecturing based. This is more about the hands-on experiences. Right? Then the second part, which will be roughly 10 hours per week workload, and that's the part when you're grouped into smaller teams and then you meet with the faculty advisor. So the faculty research advisor will give you the opportunity to visit their research facility, conduct some research, help collecting some data, and the most important part is to work with other students, mainly with graduate students and or upper division, the upper grader, the junior year, senior year students. So they could share a lot of experiences. Not all of them are transfer student, but they could show you immediately after you transfer from the community college what will be the expectation and why you need to take those calculus courses, physics courses, programming courses, and so on and so forth. And they will give you a good idea why. Okay, so that is a purpose why we want to engage you to the real world applications along with the faculty and also Cal State LA students. And they could, they are our top student. They serve as the role models and then explain to you about a career development. And also, all the tools are provided by our industrial partners, right? So sometimes the liaison also come over to visit us and share thoughts, and you can chat, and there will be events for career awareness type of things. So you could you can ask why, for example, why mechanical engineering? What types of jobs are opening there in your industry, right? How about the computer science? How about electrical engineer? How about computer engineering? How about other STEM field? What is the current state of the art? What are the current needs of the demand of the workforce? And what types of job how to prepare myself to be ready, right? These are the purpose of the not only the technical part, but also the career preparation part. All right. I listed a number of participating labs, which include the Cal State LA Circuit Space Embedded Architecture Lab, the Intellectual Medical Lab, Power and Energy Lab, ECST Makerspace. But these are the facilities that are open to you to use. And also there's some other tours to show, for example, this is a hydrogen station. It's another alternative energy source for vehicles in addition to EV. Nowadays, we know electric vehicles, but actually hydrogen stations, hydrogen is another way because hydrogen mingled with oxygen is generating what? Water. So there's no side effects. It's zero air pollution. But of course, there are a lot of technical difficulties. Hydrogen station, right? When you think about the EV, the first thing is about the facilities. Where do I charge my car? My son recently purchased a car. He graduated from college 2 years ago, and now he leased a EV car. The first thing when we travel is where do I find the charging station, right? So that becomes a different thing. Likewise, hydrogen is even harder. So there are a lot of technical complexities that have to be overcome in the future, right? But this is another tool. And I also would like to introduce you a little bit about the state of the art, Internet of Things. Nowadays, things are not only connected to your desktop computer, laptop computer, but also the smartphone, the wearable devices, even the street lamp. They could be all connected to internet. That will provide you the big data for engineers. Nowadays, big data is the thing. For example, so that's about the computer hardware, computer software to develop internet. Previously, we thought internet is used to connect your laptop workstations only, but now everything could be connected internet. not only your smartphone, but as I mentioned, the drone could be connected to internet directly. That can provide a lot of image, provide a lot of data, right? Provide a lot of useful information for what? For example, medical and health care. Nowadays, the physician could remotely give you the diagnosis because they could see through your wearable devices to see your vital signals and give you some diagnosis. Transportation, that's nothing new. Navigation, right? So you could determine, you can specify how many stops you want to go through. You want to go to the grocery store, you want to stop by your dorm to pick up something and then go back home. On the way, your mom asks you to pick up some food for dinner, right? So you can plan your route, right? That's navigation. Building automation, a lot of things could be now being autonomously done, right? So through the data, they could determine what to be planned, what would be the procedure, what would be the orders of the things, where to order the parts, and so on and so forth. The next important group of things include machine learning. For example, if this is a cyber side and this is a human side, and whenever you purchase something, the very next day, Amazon is going to provide you very targeted advertisement commercials, right? So how there's no human intervention. This is about the machine learning because the machine is telling it's based on the data you provided, which website, which for example, items you have brought through, and then based on that, there's a huge the database that they could use to determine, using some sort of neural networks to determine what you're thinking of. They're trying to predict your behavior to make suggestions of the merchandise for you. Mara said, no good, no good. We're trapped. And this is another robotic arm. Eventually, this can be connected to human nerve. It's not controlled by a gamepad or a cell phone, but instead, you can use the patient could use the nerve as to connect to the artificial part to operate the robotic arm. It's like those sci-fi movies, but it's happening. Another one is a drone launched with a camera. So the purpose of this one, was this is a research project by a faculty member. So it's funded by the government, so that it could launch the drone to a tunnel, for example, to take pictures about some cracks here and there, right? And then we use the result to give the civil engineers to determine the foundation, if there's any potential danger of the tunnel or a bridge or a road, because it's cross-disciplinary, right? So that's another example of interest. Power and energy, of course, nowadays there's the green power, the solar power versus the wind power. There's again, the charging station for EVs. So these are very common exercise nowadays. So that all involve engineering disciplines. I think I am about time to pause for you to ask questions.
Thank you for all that information, Charles. Very informative. And also, I learned something new today. When my family starts blaming me why I keep shopping so much, I can say it's not my fault. It's the targeted advertising, right? It's the machine that's studying.
Machine. That's a machine. Blame to the machine.
Blame the machine.
But that's our excuse, we all know.
Right? No, very awesome. And students, I hope you all saw like the just amazing opportunities that there are to really learn just a lot of new things, work on a project, get hands-on experience. These are all critical to, especially once you transfer over, and being able to be a better candidate for even more internship opportunities in the future, because they're already going to see, wow, this student participated at the CSULA SMART internship program and they worked on this project and they built built this and now they have these skills. So also keep in mind that with the CSULA SMART internship program, it is paid. So that's another added awesome layer. So again, skill building, networking with grad students, professors, and then the project and skill building is just amazing. So right now we are opening this up for questions. You can either unmute yourself or you can put a question in the chat and we'll go from there. And actually we'll start with one from Ansley. If we live out of state, would it be possible to only come to California for the final weeks, since you mentioned a lot can be remote, or is it better to be in California for all 8 weeks?
Right. Yeah, ideally, you can. That happens to one student. He tried, but eventually he lived in San Diego County. But eventually he still decided to join us remotely because the living cost is way too high in Southern California, in the LA area. Yeah, so there's not a requirement to stay with us physically, as I mentioned. A lot of these could be done remotely because a lot of these are just apps that you can install it on your own computer, and MATLAB, I believe, is provided in your community college, but otherwise we can provide help you to install it. Other simulation tools, of course, if it's needed, we will help you installing it so you can work on your own laptop or join remotely. For the Intel Dev Cloud part, you're using the cloud server. All right, the computational power of your laptop or desktop is not demanded because you're just logging to the cloud to use the Intel's facility. Yeah, so the answer is, of course, ideally you can come over and sometimes we have lunch together. But if you join remotely, then you're good. Then that's just fine.
And awesome, thank you. And I think that goes with Becca's question there. So next question is, I may have missed it, but what is the pay rate? And when is application open or due by? So yeah, we would have to get back to you, but I believe there is an overall stipend. I'm just don't remember the rate at the moment, but it is a paid internship. And then also the application for applying for the growth sector STEM core summer paid internships will start October 16th. So like I said, keep an eye open for email communications from your student support specialist or from us, who will be letting you know when the application goes live. And then making sure the application itself is pretty straightforward, but you do need to have your STEM resume ready. So if you don't already have one created, please make sure to get it done. If you are like, Myra, you know what, I don't even know where to start, or you know what, I'd like to have someone look over my resume that I have, not a problem. We have been sending out links to students to be able to schedule a one-on-one with our team so we can look over that for you or help you create it. But also your student support specialists are also great resources as well. So yeah, there's definitely ways to be able to get assistance with that. And it looks like the stipend will at least be $7,000 for the summer. So again, we'll get details as we get closer. And you will be made known of that, be aware of that and all that good stuff once we get closer to those dates. You know what, I actually have a question for you, Charles. For students who listened and they're like, oh my gosh, it's quite a bit of hands-on and learning how to use different programs and this and that. For a student who's interested and, really wanting to be hoping to be selected for this program, are there maybe some skill sets or programs or things that you would recommend they, if obviously they may not be experts in, but things that they should maybe already start looking at to kind of prepare for?
Yep. It's only fall, right? You have spring.
Yeah.
Yeah, still stay in the curriculum that you're pursuing right now. Calculus definitely is still helpful because that's the scientific language, right? We're using the notations, the formulations that though, as I said, is not a hard prerequisite, but it's definitely helpful to have it. Some programming, could be Java, could be C, could be Python. If you're interested, you want to self-learn it, or otherwise in the community college, it's a common lower division course, right? Could be Java, could be C, could be Python. Maybe it's a good idea to prepare yourself ahead of time. But again, we will start from beginning. And back to Becca's question, there's a dorm on campus, but with the 8-week arrangement, I am not sure this is the most cost efficient solution because I think you need to stay for the entire summer. Which is more than 8 weeks, unless you want to stay in the dorm for the entire duration. Nearby in the nearby neighborhood is not the super good neighborhood, honestly. So staying across, and also it's very, very expensive, incredibly expensive. So yeah, that's honestly the situation. But students commute to our campus by taking train or driving to us. Not every time, but maybe once a couple of weeks. That could be if you're living still in the metropolitan LA area or San Diego or Riverside, if you're still in the surrounding area. But if you're in East Coast, then fly to us. But I think there's another issue. I think Myra could clarify and verify that for me, because previously students also asked if there's compensation for moving. I don't think so. It's covered within your stipend of the scholarship, the internship, right?
Yeah, that's a great question. I would have to get more information probably from Cheryl to see. But I don't, yeah, I don't even want to say because I'm not sure.
Yeah,
So
I thought. Yeah, I thought Cheryl just mentioned it's include. Yeah, it has to be just the paid by through the internship
yeah.
if you'd
But
like to.
and we have heard of students who have family, sometimes where when they get placed in a certain area, some people have family. I mean, if you can make arrangements like that, that's always a plus too. I myself, I'm in California as well. I'm in Orange County over here down the street from Disneyland. And I myself went to Cal State LA for my graduate degree, and I drove down there. With the drive isn't too bad. It's of course lovely LA traffic, but so nothing out of this world here in California, I guess. But there's definitely things that we can help brainstorm and whatnot. But again, with that awesome option of there also being the remote opportunity, so that's always a plus too. Would having some cybersecurity knowledge skills help? A student asked over here.
Yeah, I saw that there's another question regarding how many students, how
Oh,
many
yeah.
interns. Yeah, so we're targeted the cap is around 25, but we could accommodate enough students in the past, so it shouldn't be any issue. If you're interested, I think I always convey the same message to the students. The commitment is the most important part, right? You have to be interested in it. Otherwise it's a torture. Why bother using your summertime working in the lab and then work with with those hands-on things? It's fun from the engineer's perspective. I'm very excited, but this is more about the commitment.
And also, oh, sorry, jumping onto that. when students apply for our STEM core interview, all students will get a round one interview. And during that interview, we do ask students, from after attending all these different amazing like employer speaker series events that we've had, are there some employers that jump out at you? Opportunities that you're like, oh, I really, really liked this Cal State LA thing, and I would love to be able to be considered for that. When you let us know, because we do ask you, but when you let us know, we definitely keep that in consideration. Again, nothing is guaranteed. You know, as it is sometimes, even a second interview isn't necessarily guaranteed, but again, when we're interviewing you or asking you these questions, we definitely want to know these things, because we do take a lot of different things into consideration: location, what your major is, what your interest is, just everything. So definitely let us know when that time comes.
Yeah. Yeah, and also Myra also mentioned previously, this is also a good chance, good opportunity for you to develop the knowledge, skills, and then also it shows your commitment in the engineering field. So in the past, 2 students after the STEM core internship have been hired by industry. They're working on the charging stations, but they're because we had a partner from the LADCC, that's LA District of Community College. So she helped us to recruit our students, the interns, to continue with a paid internship, external internship. It's not, this is considered internal internship within the university, but later on, the next step is a real external internship with the industry, right? So, and also one student is asking for recommendations. That's also very common exercise after the program. So I'm writing the letter of recommendations. He's applying for PhD program across the UC campuses. All right. A couple of other questions. Cybersecurity knowledge, skills helpful. Yeah, that's a it's a very popular area in computer science. Within the program, we do have a couple of computer science faculty members, not necessarily to be cybersecurity specific, but definitely, yeah, that's you always need to be mindful nowadays if there's it's going to be hacked, if this is going to be intercepted, is there malicious use of the data, all those kind of things. Yeah, that's very helpful. And again, Becca asked a question. Yeah, that's possible. The subset of families willing to rent a room. There's always the cases, but we could ask students to help Student Life to the division of Student Life to help if you're truly planning to stay during the internship. Yeah, we could find out more informations.
And you know what? One more question that popped up in my mind too, Charles, is we get this a lot from students. This is my very first year in college. I've only had one semester, a couple of computer science classes. Am I gonna be ready for this? Am I, going to be okay to even apply and be considered for this? What would you say to that?
Yeah, actually, we have a repeated STEM core intern. He attended twice in our program, and he mentioned that second time he told me, "Oh, now I see what that meant." This kind of excitement. Of course, I believe there are other activities within the STEM core, the bridge internship, and the prep for the courses. If you think this is heavy duty one, maybe you can wait till the second year. That's pretty much what we plan on the pathway. So in the beginning, there's an introduction part, and then the bridge internship, and then there will be some internal ones in your community colleges. And if you're ready to transfer, you're in year 2. But I'm not saying if you're a year 1 coming college student, you're not eligible. You can still try, as I mentioned. It's
And
more about the time. It's more about your commitment.
And I would just also add to that as well, for students who may be thinking, oh, Myra, well, I haven't had a chance to take, a class in Java or a class in SolidWorks or a class in this, also, I mean, even I always tell students, like, use the resources around you, right? If you are unable to take a class for this upcoming semester, but you have it planned in your ed plan for maybe, next year or whatever. In the meantime, hey, YouTube is a great resource, right? Do some research on your own, start tinkering, start seeing if you can look for even just resources online that can you can start playing around with, and just kind of getting an understanding for these different programs and whatnot. Because I think even just general curiosity and just kind of working along, teaching yourself with some skills, that's always a plus too. I'm personally a very crafty person, and I sometimes see things, I'm like, I could do that. And then I just start doing my research. And then before I know it, I've tinkered a little with things, and boom, I made what I was able to replicate what I saw just by kind of self-teaching myself, watching videos and stuff. So, if you feel like, oh man, I feel just a little unprepared, but I know I'm going to have these classes coming up. Again, just put a little more time into it, and start really doing some of your own research so you can feel better prepared and just feel better about it. But we definitely don't discourage you. If you're a first year, definitely still apply if you're interested, but just definitely take some time to put into doing some research yourself.
Right. Last word. Yeah, the learning environment is critical. Laziness is the mother of the invention. We're lazy, so we want to do something to help us do that. And also working with other students is a good idea, that you want to help developing something to become autonomous for supporting all different types of applications. So in the invention part needs a lot of collaboration, because if we're lazy and lay back on the couch, nothing will happen. But you need to come over, work with some peers. That's the environment that we want to develop for you, so that you can see, oh, that's going to be my future 2 year, 3 year is like this. Right? So that can motivate you and prepare yourself.
Teamwork makes a dream work. I love it.
Yeah.
Well, thank you so much, Charles. We've come to our hour. We want to respect everyone's time. Thank you, everyone, for joining today. We hope that this was insightful, and you enjoyed hearing about all the really amazing opportunities that there are with the CSULA SMART program. Again, keep an eye out for those emails coming from your support specialist or from us about the opening of the growth sector summer internship application, which again is October 16th. And remember to have those STEM resumes ready to roll. Have a great weekend, everyone. And again, thank you so much for joining. Bye, everyone.
Bye.